My name is Jane Eliasoff. I'm the director of the Montclair History Center, and this is a real live fire behind me. I'm coming to you from the Hearth Kitchen at the Crane House in historic YWCA today. Not my own home, but I certainly am here often enough that it sometimes feels like it. I'm here because we're actually doing a program for kids this afternoon, and we're cooking on the hearth for them. And it's something that if you've ever cooked on a hearth, you know you need to prepare your fire early enough in advance so that the coals are ready for it. So that's exactly what I'm doing right now. If you can see it in your heart to give a donation to us, it's always appreciated. You can do that on montclairhistory.org. You can do it via Venmo. You can do it by sending a check, and we also take Zelle. So any of those ways, if you can support us, that would be lovely. We would really appreciate that. So with that, I am going to turn it over to Dr. Greg Pope from Montclair State University, who's going to talk about an area that I know nothing about, which is real history here in Montclair. And I'm going to let him introduce himself because he's got a pretty thick CV, and I'd rather he picked and choose the ones that he think are most relevant to today's program.
Thank you very much, and thanks for coming. I'm a physical geography by degrees. As that, so I understand environmental change, climate, geology, soils, ecology, but also the human element in that. So that's given me a pretty good launching point to dabble in a lot of interesting things like archaeology and climate change and history and things like that. So, okay, so there's your panorama, and I'm estimating that scene is maybe what we might have looked like 20,000 years ago. Montclair's at the edge of the great continental ice sheet that there are numerous of them that got as far south as New Jersey, emanating out of Quebec in the Hudson Bay area. So that scene, maybe I've got more pictures like that. Maybe we'll look like that 20,000 years ago. So I'm gonna give you some little science background and why this happened, why climate's changed, what they did to the landscape around here and the ecosystems and things like that. So that's what we'll go through. Okay, so what is an ice age? Ice ages had a lot of glaciers. We'll talk about how glaciers erode and make the landscape we have, and I'll point out landscape features that we have in our neighborhoods that make northern New Jersey is a great place to be seeing this kind of thing. That slide image there is the extent of glaciers over North America, and you can see that snowy area went as far south as our mid-Atlantic area. So an ice age, which we make movies out of it. We've had a number of ice ages in the history of the Earth. So let's go back more than 1 billion years ago. So where large surfaces of the Earth are covered with ice because the climate is colder, could be for different reasons. Could be due to a weaker sun, could be due to a lack of greenhouse gases. It's actually, the natural greenhouse gases keep the planet at a temperate level, but they fluctuate over time. So this chart shows that's a span of hundreds of millions of years of geologic time. And do you see my arrow going back and forth here on the screen?
Yes, we do.
Yeah. Okay. So we're going back 500 million years, and I pointed out some areas. Dinosaurs lived in this era from like 65 to 250 million years ago. We are here at this Neogene time. And first animals, the fish that crawl up on the ocean, that's about 370 million years ago. The blue line is showing the fluctuation in Earth's temperature based on geologic evidence. We're in a kind of a warm fluctuation of a relative cold stage. We've been in this kind of a colder ice age period for the last 30 million years. Last time it was this cold was maybe 450 million years ago. This is again before land animals and maybe icy planet, but the geologists think there's at least 4 of the long ice ages. We're kind of in the colder stage now, but that's long geologic time. This shows the most recent 60 million. So this is time since the dinosaurs died off. We are down here at 0. And the green line is showing the temperatures. They fluctuate a lot. Some of it has to do with greenhouse gas. Some of it has to do with continent movements or solar fluctuations. It drops off suddenly when Antarctica becomes a southern continent and glaciers form. But since about 15 million years ago, it's been dropping off. And then we have a huge amount of variation in the last 2 million years. And that's what we have. That's the ice ages we're familiar with here in New Jersey. So here's the last 800,000 years. So less than 1 million years. We are on the far right for time. Okay, notice that between, the right side of the graph is showing literally the last 200 years. The rest of the graph is showing 800,000 years. All the blue arrows are showing where it's been a cold period. So the last ice advance of this current ice age was around 20,000 years ago. There was kind of a dramatic warming after that, as we went from Arctic conditions to temperate conditions, what we are now. Maybe slightly warmer 5,000 years ago, but then the green line is showing this is the temperature changes in the last 100 years is actually, whoops, the last 100 years are as dramatic as temperature changes that happen over several thousand years at the end of the ice age. So that's important to keep in mind. But here's times when it has also been warm, temperate, what we are now. So some of my colleagues, we study like the climate records from 120,000 years ago because that was the last time we were this warm, but we're exceeding that now. Okay, so that's kind of the climate change history in geologic time. What's a glacier? So glacier is just ice. Okay, it's has to be perennial ice that accumulated for when it doesn't melt it can melt, but it can't disappear from summer to summer. So it's perennial. It accumulates and becomes pressed and recrystallized. So it becomes it's a different type of ice than what forms on the puddle out in your front yard or the ice cubes in your refrigerator. It's harder, it's more durable, and under a lot of pressure, it flows. It comes out of mountains, it flows out of mountain valleys. That's what the top picture is showing. Or if it domes up thousands of feet thick, like currently what's over Greenland or Antarctica, or during our most recent ice advance, it was accumulating over Quebec and Hudson Bay and Labrador. And this dome, just the dome of ice presses itself out. So it's a solid, it's a crystalline ice, yet it flows. That's kind of a weird concept. It flows under its own pressure and by gravity. As it flows, it moves. It's a moving medium. It can cause erosion. And if anybody has questions as I'm going along here, feel free to unmute and say something, or if somebody's monitoring and see a hand raised, let me know. Okay, so here's different kinds of cryosphere. That's the icy planet. Okay? So we have mountain glaciers, you can see these at Glacier National Park or the Alps or different places around the world. And we have ice sheets, and that's the domes I'm talking about. Some of these creep out on the ocean as sea ice. We see that around Greenland or Antarctica. We would have seen it around New England during our recent ice event. The scale on the bottom is showing how active these things are over periods of time. So like snowfall, that lasts hours to days, right? Snow. River, lakes, and ice freeze over, last days to a couple months. Glaciers exist years to centuries in scale. And then these large systems, the big ice sheets, like they cover Antarctica, Greenland, last hundreds, thousands to even millions of years, they persist. All right, so over the entire kind of 48 United States, this map is showing where glaciers had happened in the last ice age. So we call it the Pleistocene is the geologic time. It's about the last 2.5 million years or so. So yellow was covered by ice. The squiggly gray lines are these debris ends of the moraine, the ends of the glacier they put bulldozed forward. I'll show you more of that later. But you can look at there, New Jersey and Pennsylvania, New York has had a couple of where ice has covered the northern parts of it. It's covered, the areas around the Great Lakes, in Iowa, in Missouri, at older times it covered. The mountainous areas in the west have been covered by glaciers, not in the Appalachians though, although certainly up in Maine. And the gray or brown are showing ancient lakes that existed from meltwater. All right, so here's some pictures of what glaciers look like on large scale glaciers that probably what they look like over northern New Jersey. Large dome of ice. This is hundreds to thousands of feet thick. It's got gullies in it from erosion, and all that meltwater makes these debris-filled streams. Here's volcanoes in Iceland covered by an ice dome. Here they're spreading out from an ice dome in Greenland, spreading out to the ocean, and you could see the flow. You visualize the flowing. The lines of it have that. You can see that it's solid ice, but it is moving slowly at a glacial pace, they call it, but it is moving. Right, so here's different scales. These are more mountain glaciers. There's kind of defining two halves of a glacier. There's a bright white side there and kind of a dirty side. So there's the dirty end of the glacier where it's melting mostly, and the bright white part up above is where it's still snowy and accumulating. So you have accumulation where it's snow and it's building up, and lower down where it's warmer or not accumulating much. It has the literally the dirt, the soil, the rocks, the sediment accumulates, makes it look dirty. So it has this accumulation and then ablation, the melting at the other end. So it's a net flow of ice from the top to the bottom of the glacier. I'll go briefly through this, but we think of it like if the glacier has more input, more snow on the upside than it has melting on the downside, that's positive mass balance. That means the glacier is going to move forward in advance. So glaciers started in Quebec. If it kept snowing, it kept building up, and the glacier advanced southward toward us. As the temperatures warmed, there was not as much snow accumulating. It melted back faster, so it's still flowing down or toward the south, but maybe melting back faster than it can flow. So that would be glacier retreat. And that's at times when the ice ages are ending as climates warm up. Right, here's some examples. The map on the left is in glacier. Looks pretty dirty. It's in a valley in the Himalayan mountains in or Nepal, and it's mapping how far it extended and how it is melting back. It is always flowing downhill as long as it's technically a glacier, but it's melting back faster. And this is that's it. That's the types of evidence we look for global warming. This one is not melting back here in Peru. It's got a blunt face, it's moving forward, and it's got plenty of supply up in the mountains. And that's just showing you kind of the way that the glacier move quickly through. But that's a beautiful diagram, beautiful map there. These lines, you can really see how the glacier out of these mountains. This is in Canada. And that's dirt, rocks, sediment, sand, gravel. On the sides and gets carried along. So each one of those stripes of dirt is from an intersection from another snowfield, another glacier. And this very wide glacier has, it's really, you can see how it's flowing down the valleys and carrying sediment with it. So that's important to pay attention to later. So here's another map that shows the extent of this term Wisconsin. Okay, they named the glacial advances in North America after kind of prominent either evidence, landforms like the black line is showing the edge of the glacier advance. There's piles of debris. We have a lot of it in New Jersey. Where they first recognized it was Wisconsin, so they call the most recent one that it melted, say 20 to 10,000 years ago, started maybe 80,000 years ago. That's the Wisconsin and ice advance. There's a previous one called the Illinoisan that may have been 150,000 years ago. It went as far south as southern Illinois. There's earlier ones. When I was in college, we learned there was 4 different ones. We now know there's like more than a dozen. So they kind of number them now rather than give them a state name. In Europe, they call them after the different regions of Europe, or if it's in Asia, they have different. So we're using the state names we have in North America. So the Wisconsin is the most recent one for us. That's the last imprint of glaciers in our region. And here's a kind of a cartoon. How deep was it? I get often asked that. Well, as far south as say, Perth Amboy or Morristown, that was the margin of the glacier. And as it domes up, it rises up. It does not take long to get very deep. Over some of the mountain ranges in southern New York or High Point, New Jersey, it may well have been hundreds, maybe over 1,000 feet deep. And places like Boston, this is in meters, 1,200 meters, 2,000 meters in Toronto, 3,300. We're talking, 1.5 miles deep of ice at the height of 21,000 years ago. It truly was looking like Antarctica. All right, so how do they modify the landscape? This is the Himalayas again, but the mountain ranges are sculpted by the flowing ice. And it sculpts over continental scales too. 2 types of erosion. You get a nice illustration. There's 2 ways it does it. There's a lot of gravel and debris that's at the bottom of the glacier, which abrades the surface of the earth like sandpaper. The other way to do it is glacier as it flows. Glacier, it's moving against the surface. It creates friction. Friction melts things, but when the friction lessens up a little bit, it refreezes. So I use the example of like if you yourself, and you don't have to admit this, but if you did lick a frozen pole and your tongue sticks to the frozen pole, then you rip your tongue off, you leave part of your tongue behind. That's plucking. That's when something freezes to another surface and rips off part of it. So glaciers do that. They refreeze to rock, and then as they're moving, rip the rock out. So we got abrasion, just kind of sandpaper, or plucking, which ripping out rock. That's a pleasant image, isn't it? Okay, so that's a a cartoon showing the boulders being ground along the bottom. They're making grooves and grinding marks, but also refreezing onto the bedrock. The bedrock's already cracked, so it can lift it up and bring it with it. That's where the boulders come from. So here's some mountain examples of where you see smooth rocks. We have examples of that in New Jersey. That's where it's been abraded. There's a kind of a streamlined flow. Where it's more kind of like abrupt and angular, that's where plucking has happened. So here's examples from our neighborhood. Watchung Reservation, that cliff there, that was plucked. Glaciers came over the hill as they melted and refroze onto that cliff face, that volcanic rock there, and ripping away. And then you get the boulders in your backyard down there in Montclair or West Orange or wherever you're from. A lot of those, they're plucked from somewhere else. Here's up on Mills Reservation, mile from campus where I am now. The surface there, that's that nice kind of polygon wreck, but glaciers went up and over the top of that mountain there, plucking the rocks as they go. There's a couple places on Mills Reservation where I can see scratches in the rock where abrasion has happened. So here's what abrasion looks like. You can see where the rock hammer there, that's pointing, those are scratches. Those are grooves, gouging of rock against bedrock there. Here on a granite surface, it's done the same. Sometimes the grinding, it's almost like polishing a lens, like eyeglasses or telescope lens we used to do. It's polishing it, makes it glassy looking. So it's both scratched and glassy reflection that you can sometimes see it at low sunlight. So that's evidence of glacier abrasion. That's the same carnage. Both working together, they're eroding the surface down. Okay. By eroding the rock below it, you create sediment. Where does that go? It gets entrained into the glacier and dumped either in front of it as the glacier is moving forward or melted. The glacier melts back and it leaves the dirt behind. So the analogy I use here, this is the snowplow pile at the edge of my driveway after any good snowstorm. And I call it snert, snow dirt, right? It's the dirty snow. It's got leaves, it's got gravel it's got salt, it's got dog poo, all mixed in there in the debris of the glacier, and it melts behind, and there's a small pile of gravel after that little snowdrift melts. Scale that up hundreds of thousands of times to glacier size, and this is the debris that's left behind. We've got hills of that in northern New Jersey. Formerly snert, and now it's debris left behind. It's unsorted. You've got boulders, I got sand, I got gravel, I got clay, all mixed together, no layers. And the term for that, that geologic sediment is called till. Right, so the glacier advances. There's rivers, meltwater in it that leave kind of stream deposit. It pushes ahead, kind of bulldozer-like, or it just melts back. Sometimes there's lumpy debris called a came. We have a lot of those in New Jersey. Here's the moraine, which is the ridge. It's usually more lumpy than that. There's lakes left behind. We have lots of little odd-shaped lakes in northern New Jersey left behind as land icebergs melted back. So there's these big scale moraines. We have them in New Jersey, all across the Midwest, where the glacier pushed forward and then moved, as it retreated back, it still left piles of dirt. And that's what the piles of dirt look like in an active glacier melting. It's in Iceland, I think. Or if the glacier is melting and there's plenty of water coming out of it, just Niagaras of water coming out of a melting glacier, it carries all that gravel and sand with it, depositing, down in rivers. So we have plenty of that too. So we have, so let's look at some more evidence from northern New Jersey. Evidence, we've got sediments, we've got boulders, we certainly got boulders, and we got a lot of erosion went on. Here's a couple of good examples. We got large boulders. A lot of them use them for landscaping. We've got plenty of those, and they're called erratics because they're erratic. They don't belong to the rock that's under you. They come from somewhere else. So here in Anderson Park, this is a boulder of granite gneiss that came up from upstate, some probably the highlands of New York, Bear Mountain area, maybe up there, have granite gneiss like that. That's unlike the geology under Anderson Park, which either would have been sandstone, like Newark Redstone, or the basalt from the Watchung Mountain there. So it's different. It was brought there by a glacier, something that big. Or we have spectacular erosion going on. There's Great Falls, which a lot of, I'm sure everybody's been to, that gouge in the bedrock there, that lava bedrock can only have been caused by a rapidly moving river. And I've got some evidence of that coming up in a second. Let's see. All right. Whoops. Okay. This is brand new map that came out last year. Scott Stanford is a geologist working for the New Jersey Department of Environmental Protection, the New Jersey Geological Survey part of it. They do the mapping of surface geology for the state. And he's worked for years assembling all the great evidence that New Jersey has. And New Jersey is really good at having a lot of glacial evidence. And this spectacular map, it looks psychedelic. It's really complicated. Somebody like me who studies landforms, I just love this stuff. But it gives you, it does illustrate the abundance of glacier sediments we find in northern New Jersey. So Montclair is going to be right around here. My arrows there. The farthest extent of the Wisconsin Glacier is the dark green line, and that goes from Long Island, Staten Island, up to Summit, Morristown, and out toward the Delaware River. There's a line farther south that was an earlier glaciation, sometime in the last 2 million years, went as far south as New Brunswick and Somerset. The blue is lakes. Both we got light blue and dark blue, or kind of gray blue. Those are meltwater lakes that existed in our area as the glaciers move back. Here's kind of a less colorful map, but it's showing those margins of where the glaciers were and the glaciers. So we have two really important glacial lakes here that don't exist anymore, but they're remnants do in swamps and marshlands. There's Glacial Lake Passaic, which extends, anything from like Little Falls west to Boonton and Parsippany. That big flat valley that the Passaic River occupies now was a glacial lake. There was a lake downstream from us, Lake Hackensack. So that fills the Hackensack River Valley. And there's lakes that Wallkill Valley, the Hudson Valley, of course, Long Island, Connecticut River, all had glacial lakes too. That from melted, as the glacier was melting. Here's a simplified drawing, like all this time while there's glaciers here, of course, sea level is lower. A lot of the world's water was occupied in ice, so there's actually less ocean water. We're dealing with ocean rising now as glaciers melt. Back in the time when there were more glaciers, sea levels were lower. So the continental shelf was a couple hundred miles east of us. The Hudson River flowed through a canyon, which you can still see under the ocean. That was a valley formed by the carving Hudson River, goes out the continental shelf. So that would have been all land. There were Native Americans living out there maybe, and animals that's now fled. They have dredged up mastodon bones out of the continental shelf out there offshore. Here's another kind of more bigger scale. So here we are in New Jersey, New York. As the ice melted back, this is about 13,000 years ago. So the edge of the ice sheet was up by Montreal, Lake Champlain, Burlington, Vermont. Huge. The Great Lakes are remnants of it. There's a huge lake there. It drained. There's a massive amount of meltwater coming out of Lake Champlain down the Hudson Valley and flooding through the New York City harbor area. This is just a Google map that shows you the terrain here. Okay, so you're down there at the History Center. I'm up here right now on campus. This is Watchung Mountain, which has been eroded. Here's the Passaic River kind of winding its way around the mountains, but how does it get through there? I told you there was this glacial lake back here west of us. The glacial lake's down here on the Passaic River and Hackensack River. So here's the glacial lakes. Now we are, let's see, we are right about here down Montclair. There's this is part of the Glacial Lake Hackensack system, Glacial Lake Bayonne. They name them after the local area, Lake Bayonne. So there's a lot of meltwater there. And then back west of us, on the other side of the ridge, just West Orange, Livingston, Parsippany, places like that. Pine Brook, this is a glacial lake. Where did that meltwater go? So, west of us, western New Jersey, there's like Peak West and Lake Watsessing, places like that. There are some big, some small. Anytime you see a flat place in northern New Jersey, it was probably occupied by a glacier lake. Here again, zooming up, here's Patterson, great notch. Here's Montclair down here. There's the glacial lake. West of us, the Lake Passaic, and then the Lake Hackensack. So it melts, and there's drainages. Let me go back. There's one drainage kind of south towards Somerset, towards Bridgewater. When the lake was that high, it flooded out and became, the Raritan River was its spillway. As the glaciers moved back, it exposed a low point in the ridge, which is Great Notch, and that became the new spillway. It became so there's Great Notch. Picture where Route 46 goes through, right by me, by campus here. Route 46, Route 3, the railroad goes through there. There's Great Notch Inn. That was an outlet for the lake, the huge lake. Pictured, and this is before Great Falls existed. Great Falls was still covered by ice. So the only way the spillway could work was coming out Great Notch. So I've got, so this is a zoomed in. So this is a surface geology map of Montclair, basically. So let's see, this Bloomfield Avenue is coming this way here. I'm up here, New Montclair State's right up here. This anything green there is glacier debris, stuff dropped by the glacier, melted back. Or if it's orange, it's a valley. There was a meltwater valley carrying sediment and gravel with it. So here's some local erosion features. I showed you this one earlier, the plucking erosion on top of Mills Reservation, gouging the cliff. Bigger valleys like the Hudson Valley, we look for kind of not V-shaped, but more U-shaped. A U-shaped valley. Now it depends, some on the, doesn't matter the underlying bedrock, but it's roughly U-shaped, and that's the signature of a glacier carved valley. It's partially filled in, and the Lincoln Tunnel goes under this, but the Hudson Valley is a fjord, a glacial valley filled in with ocean water. So we have, U-shaped valleys in northern New Jersey. We have leftover boulders. There's that one in Innocent Park, but some famous ones you've probably been to. The town of Glen Rock is named for a glacier boulder that was dropped there by the ice. It's an erratic. It's made out of granite that doesn't come from there. It comes from somewhere north, up in the New York Highlands. There's Tripod Rock over in Morris County that maybe some of you hiked to. It's just a weird accident of a big old boulder dropped on 3 smaller boulders that just perched there. It's fun to hike to. It's an unusual place, but they're erratics. We have lots of examples of those, and anything from landscape, your garden kind of size to the size of a small cabin. All right, so we have the way.
Interrupt you for just a moment.
Sure.
Before you go too far off of those slides that you had, you may want to refer back to them. George asks, whoa, just to make sure I understand, the Passaic River or its precursor used to flow through Great Notch. Would it have been a waterfall like the Patterson Great Falls?
That's right. That's what we think. Yep.
Wow.
This map I'm showing here shows that the Passaic or the early Hudson went backwards up. Okay, this is Great Falls is here. A river flowed. What is flowing now from Little Falls toward Patterson? An ancient river before the Ice Age flowed from Patterson toward Maine and then back out toward Summit. That reversed during the Ice Age. So before there was Great Falls, there's ice covering it, and the only way for that lake drainage and river drainage to come out was through Great Falls. There's a tiny little stream there. Well, what is that? Third River has its headwaters there, and that could not have carved that valley. The only way that notch was carved was by a previous river and glacial meltwater.
So Gray, does that answer your question? Did the break in Great Notch happen at one time in a cataclysmic flood, or was it over time?
I think there was probably a notch, a pass in there first, and it was greatly enlarged by by meltwater flowing from a glacier. We look for evidence. I have my students down just below in Upper Montclair this summer. We're doing field work in that what's the I can't think of the preserve right there on Pearl Brook. So it's a little natural area that would have been the channel for and there's large boulders in there that tiny creek would not have been able to move.
That would
You're
be
talking
Bonsall,
about the Bonsall?
Bonsall Preserve.
Bonsall, I could, yeah, names, yes, we were doing work up there last summer. Yes, Bonsall Preserve, that is an outlet channel. It's a small stream now. It would have been a raging river 18,000 years ago. So this map, if you can pick up the subtle differences here, look at the stream pattern in southern New Jersey. Southern New Jersey was not glaciated. It makes what's called dendritic pattern. It branches off into tributaries that look like, trees, right? You see that, the Wading River and the different rivers that make kind of branching off typical pattern. Northern New Jersey, it's mixed up. There's all kinds of lakes. The streams are going all over. That's the aftermath of glaciation. It's called deranged stream network. It's a classic example. Northern New Jersey has this, and that's all the result of the fact that glacially modified. There's piles of debris. There's remnant lakes. There's bedrock that's been scoured and it had time to adjust. Only 10, 20,000 years back to a more regular system. So here we are. There's Great Notch Inn, which they name after this wonderful glacial erosion feature. I don't even know if they knew that. This is a glacial outwash channel that that's it. Oh, this is showing a glacial burst in Montana, but it's a nice approximation of maybe what Great Notch looked like at 18,000 years. And here's Great Falls. Okay, after the glacier melted back far enough north past Patterson, that was lower than Great Notch, so that became the Passaic River spillway. So Lake Passaic and then the Passaic River drained over Great Falls, and that's where the present river is now, abandoning Great Notch. So I hope that makes it a little clearer. All right, so here's the glacier melting back. See, what do we look here at this landscape in Montclair? Big old chunks of ice melting back, thick rivers thick with sediment, lots and lots of water melting back. Think of okay, yes, it was the Ice Age. Yes, it's colder, but this was still the middle latitudes. We still had an occasional hot summer. The same sun we have, high summer sun at our latitudes, that was still there 20,000 years ago. So that's unlike any glacier experiences now. Greenland doesn't have that. Antarctica doesn't have that. When we had continental glaciers here, we had high summer sun, and that produced a huge amount of meltwater that's unlike anything that we have presently. So, big old chunks of glacier ice melting, leaving, gravelly streams. There's lots of evidence of that on the neighborhoods that were built on, a little gravelly sand. Under the glacier, there might have been melting to make these glacier caverns. Glacial ice, it's the way it refracts light's blue ice, they call it. So we might have had that. Here's a John Quinn is a natural history scientist who did some illustrations of what maybe northern New Jersey, New York looked like. Oops. As the ice is melting, it was like some prehistoric doors flying around, but it was forested and meltwater coming out. Here's fossil claims in our region. Let's see, so megafauna localities, so things like mastodon or elk, things like that. Plenty of examples of that in New Jersey, up the Hudson Valley. And keep in mind also that there's fossils found offshore in the dredging, things that they've done. So that exists as well. Here's some was just reading about these. So mammoths and mastodons existing in this is the meadowlands, right? The meadowlands was not meadow at that time. It was a forest, maybe spruce fir at that time. Eventually evolved to a cedar forest, but we got these things walking around. Fantastic. Here's it's a moose elk. Cervalis is the Latin name. We have fossils of that exist in New Jersey. So it's moose size, with elk-like antlers. So those existed in New Jersey. We had sand dunes in northern New Jersey and southern New Jersey. All that sediment that has, think about it, the glaciers have just left. There's not a lot of vegetation. So wind picks it up pretty easy. So we have evidence of sand dunes in like central and southern New Jersey that have blown south. So that's, we have examples of that nowadays in Arctic areas, but that existed in New Jersey. We have evidence of permafrost throughout New Jersey, from north to south, all the way down to Cape May. This is in Canada. These called polygon features. You can see the scale of these. Those are spruce trees. But these kind of like, polygon shaped, does by freeze and thaw of permafrost in the tundra. So we have evidence of that all throughout New Jersey. So it's no longer ice covered, but it is permafrost. Still very cold. This is it's a very beautiful picture. There's a huge eagle. This is the Hackensack River. Kind of an artistic example of what it may have looked like. Looks like something in Canada. Spruce and pine, and definitely not meadowlands. This is only 1,000 years, 2,000 years ago, or certainly Native Americans, living in this kind of environment. It was not meadowlands, it was forested. And so this is again with the bad movies. So there's that movie several years ago about the terrible climate change, and the ice age happened in a week, which will not happen like that. We are in a pattern of warmings and coolings in the glacial, coming and going of glaciers. We're the way that the continents are oriented nowadays, until that changes, as long as Antarctica is down in the South Pole, the oceans and long term were set up for this kind of warm cold fluctuation. We may have hit the peak warmth several thousand years ago, but maybe we're messing up that right now by adding the greenhouse gases. So if it was purely based on cycles of, we should be kind of going on a slow decline in temperature over time, but the greenhouse gas, carbon pollution that we put in the atmosphere, maybe putting a dent in it. But keep in mind, okay, so the types of climate change that we're very concerned about now with the greenhouse gases, this is happening over hundreds of years. The climate changes that I've talked about here today, these are over thousands or tens of thousands of years. So there's different types of timescales. We still have to understand the ancient climate changes to help us figure out what's going on with the current one. They're for similar reasons, but also different reasons. We know that greenhouse gases in the past are important. Some of my colleagues here are doing some fantastic work on understanding greenhouse gas accumulations in the ancient geologic past. Once we know what these base levels are and why what is happening to our atmosphere now is so weirdly unusual, that's why we study this kind of ancient climate change. But it also gives us a good sense of this neighborhood you live in that has evidence of the ancient glacial history. So if I went too fast, I'd be happy to go back and explain some things. And any other questions you got?
There was one question I know that popped up, and that was, do you ever do walking tours of Mills Reservation or Eagle Rock or any of those places?
Right. I have done that in the past. I did one actually last weekend out in Morris County for an environmental group called POW, where they protect our wildlands, wildlife and wetlands. So it's a conservation group out in Morris County. So we did just what you're saying, kind of a walk through the little park nature preserve called Jonathan's Woods. So yes, it's possible to do these. I love doing field trips. It's more off the cuff, gets you out and walking around. You can see these things in person. And Mills Reservation has interesting things to see. I've taken my students up there. We also did work down in the Bonds Reserve, but yeah, right along the ridge, that Mills Reservation and
Eagle Rock.
Eagle Rock. Those are great places you get views as well as what's under your feet and things like that. They're great to look at. So yeah, it's something we could possibly look at in the future.
Well, let's talk about it for the spring. I think that would be loads of fun. Yep. Other questions? That was fascinating to me. George, it made your 1800 map look like yesterday.
Certainly did.
I'd like to see that too. Let's see. Here's a chance. See, 50 years ago, hiked Sunset Pond in western New Jersey. That's up on the Kittatinny Ridge, right?
Sunset Pond.
Yeah, that's right. So Carol is saying Sunset Pond. My son and his uncle went hiking up there a couple years ago. So Sunset Pond is still up there, and that's what I understand. It's a glacial lake up there on top of the ridge, at the top of Kittatinny Ridge. It's a remnant of it would have been a hollowed out area that it's filled up with modern water now, but it's a little depression caused by glacier ice up there, and it's considered a glacier lake. So it's like Hopatcong. Lake Hopatcong is the largest natural lake. That's a glacial remnant. It's still fresh water. So that valley, it's been carved out by glaciers. So, but a lot of the lakes, the existing lakes, some of them enhanced a bit by dams, but a lot of the lakes in northern New Jersey, we can trace their origins to glacial erosion.
So, Greg, question for you. I know that, in Western New Jersey, there are a lot more small little lakes than there are here in this part of New Jersey. Was that something that was happening with the glaciers, or is that something later, or when did that, why? I guess is the question.
I don't know for sure, but the fact that we're here, we've had 300 years of urbanization. So there's a lot of features that are filled in. I bet there were a lot more lakes around here. Where I live, I'm more suburban. There's a lot of lakes in Morris County, little puddles here and there. Those are all glacial remnants too. So I bet there were still ponds and things. Anderson Park used to be a pond, partly a pond. So there's plenty of landfill in the urban area that may have been marshes and ponds that would have been remnants of the glacier.
Interesting. Okay.
Greg, I have a question about
Sure.
the glacial erratics you pointed out in Anderson Park.
Yes.
And I've seen your map that you've pointed out. There are maybe a half dozen glacial erratics there. I'm interested in. It's obvious that they're erratics, that they're not from there. But how do you know where they came from? You said they came from a specific location in North Jersey. How do you know that? And how do you know the age? I noticed that one of them was Precambrian, was 600 million years old. How do you date that, and how do you know its origin?
So that's the expertise. Like I'm conveying what I've been told on that. My colleague Matt Goring, he's more the petrologist, and he and his students, they could look at something. Oh, this is a granite gneiss, and I think it would come from this. So the characteristics of the rock, if you want to get very precise, they can do geochemical analysis of it, literally fingerprint. Oh, it came from Bear Mountain, or it came from such and such outcrop. That's how they do that. And part of the geochemical analysis, they do different kinds of radiometric dating to hundreds of millions, billions of years old. That's how they do that. That's a very different kind of dating than we would do in my realm of study, which is geomorphology. So much more recent surface geology things. We would use if it's within 20,000 years, like the Ice Age, we use carbon dating. Or there's other kinds of sediment dating we might use that might, take it to 100,000 years. That's a lot different than millions of years that the potassium dating that the rock people would use. Different approaches. So yeah, if one needed to know how old the erratic was, we could, that could be tested with, with the sent to a laboratory somewhere. Otherwise, we're getting kind of an arm waving guess as to, okay, that looks like the granite or gneiss that we might see in the highlands. And if it's that's the case, then other researchers have said this is about 1 billion year old or whatever. So we're kind of by inference, that's what we're doing there.
Thanks very much.
Sure.
Great question, Gray. And two other questions, one local, one not so local. One is about the new Essex Hudson Greenway that they're doing. Will that
Right.
be an interesting walk for the Ice Age, do you think?
I've read about this. Mark Chopping, he was on that committee to help get that. So he's my colleague here, and he lives in West Orange. So that sounds like a great opportunity. So I guess, there's parts of, they got to develop that as a trail, but that's gonna make a nice cross section from, it's gonna go from like, Montclair east, right?
Mhm.
That's a, we geographers love transects because you get a good sample of the terrain. So you're getting from the Watchung Mountains down the valley to the Passaic Valley to Hackensack Valley. That would be a interesting, nice bike tour opportunity. So
Mhm.
that'd be a good sample.
So stay tuned for that one. And then the
Right.
last question that's in the chat right now is, what about the Finger Lakes? Not local, but
Definitely. The Finger Lakes, they're all these narrow fingers, right?
looks like
they're-
flows.
They're all in U-shaped valleys. And so they're carved by glaciers. They were dammed up by moraines, the end moraines, and they're all oriented in the direction the glaciers flowed. So they were, that the same thing is happening here, except they're carving somewhat softer rocks up there in upstate New York, Western New York, than we have here. So it was able to carve the bedrock better into more distinct valleys, and then the valleys left over filled in with water. So those are all glacial lakes.
And they've got some beautiful waterfalls up there too.
Oh, fantastic! Yeah. So the glaciers always oversteepen the valleys, so it became what was more kind of a gradual swale. Now the very steep glacier valley that plunge off the edges and fill them in. So great place for waterfalls. Exactly.
Yeah, and David says, and you can see drumlins north of the Finger Lakes.
That's
I don't
right.
know what a drumlin is.
Okay, a drumlin, those are cool. They are kind of spoon-shaped, half egg-shaped hills. They're streamlined. They are streamlined in the direction of the ice, so they form under a glacier. They made out of sediment that gets trapped under the glacier, and then sculpted by the glacier as it moves over the sediment into these little hills, and they have to happen in swarms. Like there are dozens of them across a flatland area. You see them up in Newburgh, New York. We have a few in northern New Jersey. Finger Lakes has plenty of them. So they happen in swarms. They're glacial sediments, streamlined shape formed under a glacier.
Fascinating. Okay. Anybody else before we wrap up? It's right 2 o'clock. So thank you for rearranging your schedule today to come at 1 instead of 12. It was certainly worth it. Thank you. And we'll be on again tonight if you want to share it with your friends, or if you decide you have a burning question that you didn't get asked today,
Right.
and want to ask it tonight, you can do that. 2 weeks from today, we're only doing a 7 o'clock, and that is called Remember the Ladies. But I hope to also see you in person at some of our upcoming holiday programs. The Candlelight Tour is one of my favorite, and we've got 4 opportunities to sign up for one of those. So take a look at our website, and we hope to see you soon. So thank you, everybody.
Yeah, thank
Great
you,
job.
everyone.
Thank you.
Thanks.
Thank you.
Thank you, Greg.